Hi, everybody. We'll get started in just a minute. Don't forget you can use the chat feature on Facebook, Twitch, and YouTube to get your questions answered by the instructor. So we'll get started in just a minute. Hi, everybody. Welcome to another exciting episode of FIRST Robotics Workshop. My name is Jason Arms, and I'm the president of FIRST RGV, a proud delivery partner for FIRST and a member of FIRST in Texas. Today, we're going to be visited by Dylan Watson from the mighty BroncBotz in San Antonio, Team 3481. He's been with us before to do some other tech stuff. But today he's going to be specifically talking about C++. Just some shameless plugs. Don't forget you can join our Discord, firstrgv.me/Discord, and post your questions online on YouTube, Twitter, YouTube, Facebook Live, and on Twitch. And I'll turn it over to Dylan. Welcome, Dylan.
Awesome. Good afternoon, I guess, everybody. So yeah, my name is Dylan. I'm the programming mentor for the FRC 3481 BroncBotz. And before we hop into it, I am going to go into the chat, the live chat, and I'm going to paste in a link to the presentation I'm going to be giving. That way, if you want to follow along or go back and forth through the slides, you can do that. So I've put that link in there. And then let's get right into the presentation. Let me take the time to share my screen real quick. All right, so I know that this was slotted as a 2-hour session from 1 to 3 on C++ and FRC. I'm going to do my best to break it into 2 parts. Hopefully the break will fall right around the hour mark. And that way you're not sitting here for too long. We can take, a quick 5-minute break in the middle if everybody's wanting that, go get some water and whatever. So the 2 parts that I want to break this session into is an intro to C++ as a general programming language. And then I additionally want to talk about C++ specifically as it applies to FRC, because FRC requires a lot of different things that you won't necessarily learn in, let's say, a college C++ course. But also, C++ has a lot of things that you don't necessarily need for FRC. So I'm going to try to make sure that I go over the stuff that you need. So first off, a little bit about me. My name is Dylan Watson. I am an alum of FRC 3481 BroncBotz. I was the team captain in 2019 and the programming lead before that. I'm now the head programming mentor, and I'm a cybersecurity major over at the University of Texas San Antonio, as well as a member of the UTSA Top Scholar program. So let's start off with some C++ basics. And for those of you who are already familiar with the basics, I'm going to try not to take too long if you're already a programmer, let's say specifically if you know Java or something. But I do think it's important that we go over this for everybody who maybe isn't quite as familiar with the inner workings of the language. So let's start to walk through this. So beginner's notes. The first thing that is important to note for any new C++ programmer is basic programming stuff. Every statement ends with a semicolon, a double slash or slash asterisk marks a comment in the code. Comments don't impact code, they're for your own notes. And then I put this down here just so you guys know in the sample code I'll be showing you. Anytime you see this std:, colon colon C out with this operator here, that's a print statement. So that will print out to like the console. So for example, on your driver station for FRC, you'll get an output from that. Moving on. So let's examine at the very basic, the most basic area, a basic C++ program structure. So all C++ programs are going to have include statements at the top, and those are going to include pieces of code that are not accessible by default. And we will see, the reason I put the link in the chat for this is so that maybe you can be looking at a slide like this when I move on to the next slide, which has actually got a piece of sample code on it, so that you can flip back and forth. But if anybody needs me to go back and recover something, please put something in the chat, and I think Mr. Arms will read that out to me as they come in. So yeah, every piece of C++ is probably going to have an include statement. That'll include pieces of code that are not accessible by default. So for example, in FRC, you'll see a bunch of include statements, and I'll show you what those look like in a minute, to include different pieces of the FRC library. The same thing exists with just normal C++. Then, usually right under that, every C++ program begins with a main function. So that's a piece of code that can be run over and over and over again, is what a function is. Now, the important part for a function is, well, let me back up. The reason that we use a function is so that you don't have redundancies in your code. So that if you want to call, let's say, a group of code over and over and over again with different parameters, different values, but you want it to do the same logic every time, you don't have to write that code, right? Over and over and over again. And so we define a function called main, and we loop, and that's the starting point of the program. So anytime you see main in a C++ program, that's where it's going to start. And it's very similar for Java and languages like that. So that's the first block of code to be running your program. So if we move on and we look at a very simple piece of standard code here, we can see that you've got your include here, and this is a C++ include. This includes all of the functions to deal with input and output to the console, right? So you do need that in FRC if you want to write out to the driver station console, you want to log something, tell the driver something, put in debugging statements to see where your code is broken. You're going to need that include IO stream there to make sure that you can actually adequately print out to the console itself. Then we've got this int main with these pair of parentheses and these curly brackets here. They're called braces. I call them curly brackets. I'm not necessarily going to teach you function syntax yet, but what I am going to tell you is that that is your main method. That's the entry point of your program. And in between the curly braces is the function block that is going to be run at the beginning of the code. So the first line of code that will run is this stdc out, which we talked about earlier, is the print statement, right? So all this piece of code is doing is when it starts, it will print out to the console, hello world. That is your hello world program in C, okay? So moving on from that, now let's talk about variables and types. And I'm going through this quick because I'm hoping that most people already have, I'm assuming that most people already have a basic knowledge of programming. I'm going for this for the people who might not, and then we'll get on to more complex stuff in just a little bit. So bear with me. Variables are pieces of memory that can be manipulated, written to and read from. So at the end of the day, your computer stores everything it can, everything that it does in memory, right? And memory has different addresses, different places the computer can store things. Variables is a specific piece of memory that can have values written to it and read from it. So what does that mean? Let's go over variable declaration really quickly. So variable declaration is how you inform your C++ compiler to reserve memory for a given variable, and it must include the variable type. So we've got, let's say I want to store a number. I have to tell the program, hey, we're about to store a number in memory. Then I do something called variable initialization, which is, okay, now that I've told you we're going to store a number, here's the number I want to store, right? I can't just give it a number because it didn't know it was trying to store a number first. So everything in code has to be done very sequentially. And this can be done at the same time or later than the declaration. Next, we have types. So different variables can have different types within C++. And there's a lot of different types. I outlined here kind of the 4 basic, I think they're called common or base types, depending on what language you use. And so variables have different types depending on the information they store. So an int, and by the way, all of these words here on the left that are bolded are all what's called reserved words in C++. So every language has reserved keywords, words that you can't use normally because they mean something to the language. So these are some of them. For example, int means you're storing an integer. Double is a decimal. Fun fact, it's called double because in ye olden days of the 1990s, most people would have stored decimals in a variable type called a float because it's a floating point number. But floats didn't have that much storage space, so they came up with a variable type that has double the storage space of a float, and lo and behold, it's called a double. A Boolean, abbreviated to bool, which is either true or false, 1 or 0. I'm sure if you've taken a logic class, if any of you are in college, you've got your Boolean math, Boolean arithmetic, stuff like that. And then a char, and a char is a character. So A, B, C, D, 1, 2, 3, something like that. So now let's look at actual variable declaration. So there's very specific syntax for what you're going to do. Declaration goes with the format type space identifier semicolon. Now, the type is only listed when you're creating a new variable, as you can see on your second bullet point there. So the type, int, bool, char, double, those declare to the compiler, hey, I want a new variable and I want it to be of this type, right? If the variable already exists and it is already being used somewhere else in the program, you don't necessarily need to declare that type out, right out. And then the identifier is the name you will reference this variable by. You get to choose what you call your variable name. There are certain rules about it, like I don't think your variable name can start with a number, although I could be wrong on that. But typically, just make it a word and you'll be doing well. Then you've got initialization. Initialization is your identifier equals, so that's an assignment operator. We'll get to that later, but basically it's assigning a value to the variable. It equals the initial value. And then assignment is the, that's supposed to say identifier, not identified, my bad, equals value. So let's look at this in practice here. So if we look at lines 5 through 7, we have that same main function we were talking about earlier. And then we've got lines 5 through 7. So this is a declaration of a variable called I. So there's your type, and there's your identifier right there. So your type is int. So hey, I want a new variable that's storing an integer, and then I want it to be called I. Cool. Initialization on line 6. It's called initialization because that is the first time when you're setting a value to I. Before that, I has no value. The space in memory is reserved for, but it's not storing anything. Now I equals 5. So if we were to reference I later, it's equal to 5. On line 7, that's reassignment. So now I equals 6. The 5 is gone. I is now equal to 6. A variable can hold one thing at a time, right? So it's either equal to 5 or 6. First it was 5, and then we reset it to 6, basically. The alternative way to do this, so before we had declaration, then initialization. Here on line 5, you can see we do declaration and initialization in the same line. Int I equals 5. Int meaning two things. A, create a new variable, and B, have it be of type int. I, your identifier, what we want to call it, equals 5. And then the semicolon. Now let's talk about operators. So in C++, there's a lot of different operators that you can use. And this is, I'm not going to go through an exhaustive list of all of them. You can look them up if you want. I'm not going through like bitwise logic or anything, but just as a general like overview, we're going to go over these. So your first thing is your assignment operator, and that assigns values to variables to values. So basically, it can make your variable equal something, hence the use of the equal sign, right? Arithmetic operators, you probably recognize most of these. Add, subtract, multiply, which is an asterisk, divide, which is a slash. And then modulo. Modulo is a percent. I doubt you'll use it much in FRC. You'll use it more in a computer science course. But basically, think of modulo like a remainder math function. So 6 modulo 5 would be 1 because 6 divided by 5 has a remainder of 1. It basically only divides the whole number, and then instead of decimal, it does remainder and returns the remainder to you. So you can see if I have int a equals 5, and that's your declaration initialization, int b equals 6, and then int c. C is going to be our result for this one. C equals a times b. C is equal to 30 because 5 times 6. C is equal to a plus b. C is equal to 11. An important thing to note, and the reason why I included this slide, is that a and b are not modified by 9 and 10. A is still 5 and b is still 6 because I didn't set a or b equal to anything. all I did was multiply them by each other and then set that result to C. And if that's confusing, drop something in the chat and I can go over it again. But I'm assuming that you all kind of have a basic knowledge of this, which is why I'm kind of breezing through it. But if you're confused, please drop something in the chat. Next is the compound assignment operators. That probably should have been, I don't know if that's compound assignment or compound operator. I might have had a typo there. And it modifies the current value of a variable by performing an operation on it. So these are plus equals, minus equals, times equals, divide equals. It's basically your arithmetic operators followed by equals. And what that's doing is it's saying add, subtract, multiply, whatever, this value to the current value of the variable. And we'll see that used in just a moment. Then you've got your increment and decrement operators. So increasing or decreasing a value by 1, that's shorthand. And then your comparison operators. And this is, I ran out of space on the slide, so the next slide's going to finish off the comparison operators. But the comparison operators allows us to determine the relation between two variables. So whether they're equal using the equal to operator, whether they're not equal using the not equal to operator, right? That can help us really determine how these two variables interact with each other. So for example, if we look at the compound and increment operators, we can see, again, the same scenario, A equals 5, B equals 6. A plus equals 5. That's saying take the current value of A and add 5 to it, and then set A equal to that result. So A would now be equal to 10, because 5 plus 5 is 10. It's the same thing as writing A equals A plus 5. It's simply a more efficient way of writing it. And I think I got a chat message. Oh, sorry. So I just want to clarify. I didn't mean that compound assignment should be assignment operator. Let me go back here. This should have said compound assignment operator. I just forgot the word operator. That's all I was saying. So the name of this type of operator here is a compound assignment. And the reason for that is it assigns using equals, but it also compounds using one of the arithmetic functions. So for example, it like in this example over here, A plus equals 5, it does 5 plus 5, it compounds that, and then assigns that value to the variable A, making A 10. Same thing here, A times equals A is now equal to 100. Now, some of you might be saying, wait a second, A times equals A, wouldn't that be 25? Because A is 5 here, A times 5 is 25 equals A. That's not the case, because remember here, I'm hoping you guys can see my mouse. But here on where we said A plus equals 5, we reset A to 10. So later on, when we reference A is now 10. So when I say A times equals A, I'm saying 10 times 10, not 5 times 5, right? And then you've got your increment operator, which is B plus plus, right? So plus plus just is the same as plus equals 1, or B equals B plus 1, so it just adds 1 to the value. Same with minus minus, subtracts 1 from the value. Your other comparison operators are going to look like your less than, greater than, less than or equal to, or greater than or equal to. So that's pretty self-explanatory. I think most of us have done math. Basically, it'll return true if they're true. It'll return false if it's false. So if I say A equals equals, and we talked about equals equals back here, right? A equals equals B. Well, if A and B are the same, it'll return true. And if A and B are different, they're not equal to, so they'll return false. Not equal to, this exclamation mark equals, will do the opposite of that, the inverse. So if I say A is 5 and B is 5, and then I go, A is not equal to 5, that would actually be false, because I'm checking if they're not equal and they are equal. And then last, we have our logical operators. Our logical operators, the ones you need to know, are and, or, and not. So and will check. So for example, if we have two conditions we want to deal with, it'll check for both of them. Or we'll check for only one of them, right? So if this one's true, or if this one's true. And then not will inverse it. So if it's true, it becomes false. If it's false, it becomes true. So let's look at that in practice, because I understand that me talking about it could probably make it a little confusing. Again, A equals 5, B is 6. Now we have a Boolean of C. And if anyone remembers, a Boolean is true or false. So if I say C equals A equals B, I'm checking to see if A and B are the same using the equal to operator. They're not. A is 5, B is 6, and so C is therefore false. However, on the next line, I'm checking if A is not equal to B. A is not equal to B because 1 is 5 and 1 is 6. So that not equal to operator is going to return true. So C would be true, as you can see in the comments over here. And then again, if I check if B is greater than A, C is true. But if I check if B is greater than A and A is 4, C is false, because the left-hand condition, the B is greater than A, was true, right? That returned true. But the right-hand condition returned false. And with an and statement, this double and percent right here, all of the things you string together with an and statement need to be true. Now, if I had ors in there, the double pipes, an or would have returned true because an or only requires one of these to be true. All right, next, let's talk about control structures. And we're getting into a little bit more advanced, definitely still in programming basics, but we're getting there. Control structures, wow, I can't talk. Control structures control the flow of the code, and they control what happens when. So it would be very, very difficult to write a piece of code if every single time you ran it, it ran the exact same. So it always ran the exact same lines of code. Instead, what we can do is we can check for conditions. And depending on if that condition is true or false, we can run different commands, different types of code. And it follows the if, else model. So we can say, if something is true, do this. Else, if something else is true, do something else. Else, so that's like a catch-all for if anything else happens, run this. It only runs code if a certain condition is met, allows for more dynamic code. And if a condition is not met, then it will not run that code. So let's look at conditional statements. So conditional statements are as follows. We have int a equals 5 and b equals 6, right? The same thing we've been looking at. If a is greater than b, we're going to print a greater than b. Else if b greater than a, we're going to print b greater than a. Else they're equal, because if it's not greater than and it's not less than, right? Or if a isn't greater than b and also b isn't greater than a, then they have to be the same, right? So what you'll notice is that in this particular scenario, and if I was in front of a live audience, I would ask you which track or which condition it'll follow. But if we've got a greater than b, that's not true because 5 isn't greater than 6. So it's going to skip everything inside these curly brackets and drop down to the else if. Else if b is greater than a, b is greater than a, so it's going to go in here. Now, once in a block like this, once it meets a condition and it runs that, once it finishes that condition, it's going to jump to the end. So it's not even going to bother with the else. It's going to come down here and be done. So the only output you will see from this program is b greater than a. The next control structure I want to go over is loops. So similarly to the if statement, they check a condition, but what they do is they run the same code over and over and over and over and over again until that condition is met. A while loop runs a set of commands while a condition is true. A for loop increments a variable every iteration until the variable fills a condition. For loops are a little bit more confusing, but probably a lot more versatile. And if you need an in-depth thing on for loops, you can drop it in the chat and I'll let you know about it. Or you can look it up. There's plenty of good tutorials out there. So loops. This on the left is a simple while loop. So I have a equals 0. While a is less than 5. So is a less than 5? Yes. Oops, my bad. That returns true. So then we're going to print hello, a++. That increments a by 1, as we learned earlier. It's going to come back up to the top because it's a loop. It's going to check again. Is a less than 5? Well, now a is 1. It's going to run it again and again and again and again until a equals 5. Then this condition is no longer true. So it's going to jump down here and be done with the loop. That's why the output will be 5 hellos. Over in the for loop, the syntax of for loops are a little weird, and I encourage you to learn about them on your own. But basically, int a equals 0, make a new variable. Then the condition follows after that. A is less than 5. And then what we do at the end of each loop to increment, so a++. So this will actually have the same output as the while loop. So now let's get into a little bit of C++ intermediate, but I'm going to pause just for a quick second to ask if anybody has any questions. This isn't the second session yet. There's plenty more to do in the first session, but I really want to make sure that everybody at least mostly understands that first section before I move on to the intermediate. So I'm going to give you just a minute to put stuff in the chat and for Mr. Arms to maybe relay it to me. And if you're good, if you just want to hit me up with like a thumbs up or like a all good, that'd be awesome too. Could I give an example of how a loop is used in FRC programming from Mr. Mike Henry? Okay, yes. So a loop in FRC programming. Let's talk about that. And that'll be gone over in the second session. But when you're using a loop, for example, let's say you had well, the most basic example actually is that FRC programming in and of itself is a loop, and you won't necessarily see the loop being used, but it runs the same commands over and over and over again to check joystick value, set joystick value to the motor. Then do it again, check joystick value, set joystick value to the motor over and over and over again, a bunch of times a second, right? As far as yourself using a loop, so for example, if you wanted to say run, I hope everybody's familiar with the idea of encoders, right? Encoders count how far your wheels have spun. Let's say I want to run my wheels until my encoder position equals X, and X is some arbitrary number. You've done some math and shows it. You would loop, check to see if the encoder value is at X yet. If it's not, run the motor. If it is, then we're done, right? And you would loop that over and over and over again. So it would be like while encoder value is less than target, run the motor. So stuff like that. All right, let's take a look at the C++ intermediate. And this is where a lot of kids, so I mentor, like I said, I mentor 3481. I also help out a lot of other people in the San Antonio area. And so this is where a lot of people get tripped up, is more on the intermediate stages of this. And this is the part that it's really important that you know. So my mentor when I was in high school, his name's Ryan. He taught me how to code. He told me that one of the worst things you can be is a cargo cultist. I don't know why he used that name, but basically what he meant was don't just copy and paste code without understanding it. Work until you understand the code. It's okay to take tutorials and stuff from other people and to even take other people's code if they'll let you have it, but you better make sure you understand it. That way, if it breaks, you can fix it. So the first thing I want to go over is pointers. So a pointer is a variable that contains a memory location. So instead of a variable that contains a value, it points to a location in memory that's storing a value. And we'll go over it in a little while, but it can point to an array or an object. We didn't go over arrays. Arrays are basically lists. If you need an array, you can look up how to do that. That's kind of outside of the scope of this. Or an object, and we will go over objects because that's very important. It allows for use of classes and passing by reference, and we'll go over that as well. It's the backbone of C++ and FRC. So I really want to make sure I get this out to you guys before we start going over FRC C++. Now, so passing by reference. We haven't talked about functions yet. So one thing that I'm going to do really quick, because I think the next, yeah, that's going to be confusing to you if we don't go through functions. So let's actually take some time. We have some time here. I'm going to share out a different thing here. And we're going to go over functions. Can everybody see that? Mr. Arms, can you just verify with me that you can see my programming screen? All right, hang on. I got a chat message here. Okay, we can see it. Awesome. All right, so I'm going to create what we determined to be a basic C++ program. All right, cool. So that's your basic C++ program, right? We've got A and B. Now, let's say I wanted a function that I could calculate A times B, right? And this is really like stupid simple. You would never actually write a function to calculate A times B, but it's a proof of concept, right? So I want to be able to calculate A times B. Well, I could write, and I want to print it out. Let's say I want to print it out to the terminal, right? Or to the console. So we learned earlier that this is the printout statement. And then I could print out just like that, right? And that would print out the result of A plus B. I may or may not need those parentheses. I don't remember. So we're just going to leave them there. But let's say I wanted to print out the results of a number times another number all the way from 1 to 10 on each number. Let's just say we wanted to do something like that. So one of the things we could do is we could go in here and we could go, 1 and 1, and then we could go A equals 2, B equals 2. Oops, that shouldn't say count. My bad. I'm sure somebody was confused. A times B. And then reset it, right? But the better way to do this would be to actually make what's called a function, which, as we determined earlier, is a piece of code that can be run over and over and over again. And so functions have a couple different things. They have arguments that they take in. So they take an argument, so a value that's passed to them that they use as a variable. And then they also have a return type. So they can send values back to where they were called from. So for example, if I have int, I'm just going to call it mult. So that's a function. And we're going to pass it an argument of x and y. So it's expecting to get x and y every time it does this. And then it's just going to return x times y. And I'm hoping that most of you already know how functions work, but we're going over it just in case. So let's see. Now what we could do instead of A times B here, I'm actually going to get rid of A and B. I could stdc out mult 1 and 1. Mult 1 and 2, et cetera, et cetera, et cetera. And mult 1 and 1 would give 1, mult 1 and 2 would give 2. So it's running the same code. It's running this x times y in this mult function, but we're giving it a different value. So it passes a value here and here, and it grabs that value. And this is called passing by value. It gives that value to the mult function and returns it back. And then that return value is getting put into the std cout function. Does that make sense to everybody? I'll give you a second to put in your questions. I need to turn on my fan, actually. Oh, okay. Sorry about that, y'all. I am sweltering in here. All right. So now let's talk about, I think we've kind of gone over functions. They can take in parameters. They can return a value. This int here determines that mult will be returning an int back to where it was called from, and this is calling mult itself. This is called a function call. This is a function definition. And a 1 and 1 are being assigned to x and a y in here, and then 1 and 2 are being assigned to x and y. So if anyone has any questions over functions, because I know this can be a little bit confusing and I did a really, really fast explanation of that, please let me know in the chat. I'd be more than happy to answer questions about functions. So let's go ahead and share again the PowerPoint. So what we just did with that mult function is pass by value. So if we had changed x and y, it wouldn't have changed the numbers in the main program. So for example, if we had passed a and b to x and y, if we had passed a and b to mult, x and y would have become equal to a and b. But if you change x and y, a and b would have been the same. That's called passing by value. Passing by reference is a little bit different because pointers store the location of a value in memory, it allows you to, when you change the pointer, when you change whatever the pointer is pointed to, the value of that, it changes everywhere. So let's look at this here. Pass by value, pass by reference. So we're going to walk through this. We've got the include IO stream. Don't worry about the using namespace std. That just means that you don't have to put the std before cout. And then what we're going to be doing is something with a swap method. So int main, that's where we start, right? X is 5, y is 6. Cout before, and this is just fancy. This is basically just printing out x and y. So you can see in the first line of output before x equals 5, y equals 6, right at the bottom. Then we're going to call swap x and y. That's going to drop down to here, right? Which is going to be the method, okay? The function, that is. And it takes in a parameter first, which is going to be set to the value of x. Second, set to the value of y. Were the integers swapped? After, and you'll notice that the after output on this left side is the same as the first one. The integers were not swapped, even though here we're creating a temp variable, setting temp equal to first, first equal to second, second equal to temp. Basically, we took first and second and swapped their values. But you'll notice x and y didn't swap because it is a pass by value system. Basically, first was made into a copy of x and second was made into a copy of y. Right? And so it didn't edit the original x and y. Now, if we look on the right-hand side, it looks almost the same, except in this method declaration, we include these ampersands. Now, we're going to learn about the ampersand, the single ampersand here by itself in just a minute. But basically, the ampersand is the address of operator. So it's creating pointers here. Instead of passing in the value of first, it's passing in the location in memory of first. The actual location of here's where first is stored. And then we're flipping that around. So what we're doing is we're saying the first variable, the address of it is now where the second address was. And so now x is looking at y's value and y is looking at x's value. So they swapped, which is why at the bottom here, you can see x equals 6, y equals 5. It's very important. Does that make sense to everybody? I'm going to move on, but if you say something in the chat, I will see it, and then I'll let you know. Or I'll go over it again. So what we were just looking at was the address of operator, the ampersand. So let's talk about pointer declaration. So the asterisk identifies it as a pointer, defined as the type it is pointing to. So it needs to know a couple of things. The asterisk tells it, hey, we're making a new variable, and that variable is a pointer. It's pointing to an area in memory, in the computer's memory where a value is stored. The type is the type of the value that it's pointing to. So it's pointing to memory, whatever's stored at that memory, what that type is, int, bool, char, whatever. And then the identifier, you already know that's the name you can give your variable. Then you've got the dereference operator, which is the asterisk, just like multiplication, but it's used differently. It allows us to access the value in a pointer. So obviously the pointer doesn't store the value. It stores the location the value is at. So this allows us to look at that location and say, oh, the value at that location is, whatever, it'll retrieve it. Then the address of operator allows us to access the numerical location of a variable. So if I have int x equals 5, x will be 5, but ampersand x will be the memory location of x, where that is. And then I can set a pointer equal to ampersand x to have it look at x. Pointers should be freed. Lastly, you don't want to have memory leaks. C++ has these things called memory leaks. If you make a pointer at the end of your program, you should free it. It's literally just call a method called free and you pass in the pointer, which I did not free my pointers in this example I'm giving you, so I'm very sorry. So first of all, let's look at, can y'all see the very top here? I want to make sure that I have my zoom toolbar at the top. I want to make sure you can see this image all the way, or if it's being blocked. I hope it's not blocked. If it is, somebody please say something. Basically, Got a chat. Let's see. You can see it. Okay, perfect. For me, there's the little zoom toolbar there. So I just wanted to make sure you couldn't see that. So you've got this box here, and this box represents a location in memory, and this 0x blah, 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 blah. That's a memory address. That is the address of the location of memory, kind of like where you can find it. Just like your address is where I can find you at your house, right? So this is your pointer, right? Your pointer has its own address it's stored at, and we don't really care about that. But then the pointer's value is the address of where the value we want is stored. So if we were to take the value of the pointer, take that as an address and look at where that address is and take the value at that address, there's your variable. And then you can see the way to get to here is to do PTR, assuming your variable is called PTR, with an asterisk in front of it. And so you can always come back to these slides. They're going to be posted on the BroncBotz website to really look at this diagram, because I find this diagram very helpful. And then we can see down here. So int I equals 5, int asterisk p, so that's a pointer, equals %i. So set the value of p to the address of I. The place where I is stored, we're going to set p to that place, to point at that place. So we've got std cout I, we're going to print I, and that prints 5. std cout asterisk p, that also prints 5, right? Because that's a dereference operator there that we learned about back here, allows us to access the value that the pointer points at, the value the pointer points at, right? So p is pointing at I, and so it's accessing the value of I. Next, you have the %i, that's the address of I, and p, the value of p, not the value of where it's pointing at, but the actual place it's pointing at, also the address of I. So this can really help you conceptualize how pointers work. Now that we understand pointers, I want to talk to you about objects. Objects are incredibly important. C++ is an object-oriented, or some people would call it object-oriented. Some people would say it's pseudo-object-oriented. Either way, to the extent that it is C, one of the things that C++ added on top of C is objects. So an object is basically a group of code that can all be stored in memory at once, and it can have many variables and functions inside of it. Multiple instances can be made of the same object. So they all have the same variables, the same functions, but those variables can be set to different values. So let's say you had an object called drivetrain. You could then set that drivetrain with your motors. But for different robots, those motors would have different attributes. They'd go different directions. They would run differently, right? But each drivetrain class or object all has motors. Instances of these objects can be stored in a pointer. You use the new keyword to generate a pointer for an object. Passes by reference. So we talked about passing by reference, how it actually affects the original variable. And it's the main way that large applications, including FRC code, is built. So this image is actually a really good visualization for this. So objects. Your class is called box. Private data members, public data members. You don't really need to know what private and public are for FRC. But basically, you would have your functions in here. You'd have your variables in here, right? Sorry, I'm yawning. I feel super bad. You have your functions and your variables in here. But then you could make, and it's called box, but you could make multiple boxes. B1, B2, B3. They would all have the same variables and the same functions. But let's say I had a variable called height and a variable called width for, height of your box and width of your box, because it's a cardboard box. Each box, would have height, width, maybe a function called open, maybe a function called close, maybe a function called cut up with a box knife and throw in the recycle bin because it's made out of cardboard, whatever. But these box instantiations or instances could have, one box could be a 5 foot by 5 foot box. That's a huge box. One box could be a 5 inch by 5 inch box. That's a small box, right? They're also boxes. They all have the same variables. But they are all different as far as the values they're storing. So if we look at objects again, and this is, you can see the watermark. This is not my image, but I found it, and so I didn't feel like rewriting it because this is easier. On the right hand, you've got your static void main, but first let's look at this class. So an object in C++ is identified by this class keyword, and then everything inside the curly braces or the curly brackets are part of that class. So for example, I have a string. Now we haven't gone over strings yet, but strings in C++ are a bunch of characters put together. So a string is just like a word and it's surrounded in quotes. String name, int age, so an integer age. So it looks like it's a person, right? This class represents a person. Each person has a name, each person has an age, but everybody's name and age can be different. So void set data, string n, int a, so that's a function. That function takes in parameters n and a, and then we're setting name and age to n and a respectively. Then show data, this function, which doesn't take in any parameters, will simply write the name and age. This console.write line, I didn't realize until just now, this is C#. This is not C++. That's my bad. So imagine this as a C out line. I guess I should have rewritten this. I didn't realize that until right now as I just said it. So imagine that as the std C out line that we're talking about earlier. And then over here, you've got your objects. We use the new keyword. In C++, there would be an asterisk here because it would be a pointer. And then object1.set data, pass it RAM, pass it 20, pass it sham, I'm not sure, and pass it 10. And then show data. Object 1 would print RAM and 20. Object 2 would print sham, and it should be 10. Whoever made this screwed it up because that says 20. But I hope that makes sense to everybody. So basically, they all have the same variables and the same functions, but you can set different values to those variables and then call functions with those values. So it's 11:47 right now. I want to take the last, we can go anywhere from 3 to 5 to 10 minutes, whatever, on questions. These slides will be posted on our resources page on broncbotz.org. And then again, at 2, we're going to look at C++ specifically as it pertains to FRC. But I want to take this time for questions, and then I want to give you all a quick break. And then at 2, we will jump back into FRC C++ and actually programming a robot. So I'm going to sit here for a few minutes, probably until 1. What is a good source to find some sample code for robots? Okay, cool. So I will talk about this for sure more next session because that's kind of the more robot-centric session. But sample code for robots. A lot of good tutorials online. WPILib screen steps is a good one. Additionally, the VS Code thing, and I'm going to show you this in the next session, so stay tuned. But the VS Code kind of way that you write FRC code, when you create a new project, there's actually an examples tab. We're going to be walking through one of those examples today. And that has some really good examples in sample code. Other than that, any team that writes code outside of their season, outside of build season, has to have at least a code they wrote outside of build season published online somewhere. So most bigger teams, you can find their code. So if there's something you're interested in looking at, it's online. Additionally, Chief Delphi, if you're not familiar with Chief Delphi, just Google Chief Delphi. It's basically the Reddit for FRC. Also a great place to find code advice. You make a post on there, you're like, hey, I'm a rookie programmer. Where do I get started? Does anyone have any good sources? People will flood you with sources and examples and stuff like that. Let's see, those are the big places that I can think of. The BroncBotz website also isn't bad. I believe we have some resources up on here. And you know what? I accidentally linked this to our FTC page. I copied the wrong link, but you should see FRC in the drop down there. So yeah, thanks for asking. Does that answer your question? And do we have any more questions? Like I said, I'm going to be here until 1:55, and then I'm going to probably go get some water for 5 minutes, and then I will be back at 2, but I'll be here for another 5 minutes to answer questions before I go get water. All right. The other thing I'm going to tell you is that if you enjoy this stuff, if you know, I know I'm going a little bit fast because there's a lot to cover to actually really write code along with me. If something that you all would enjoy, and I don't know how many participants we have here, so I don't really know how many people I'm talking to. Um, but if something you guys would enjoy, and I'm going to do a little bit of this in the next session, but for a big thing like a programming live stream, if that's something you guys would like, please put it in the chat, and then Mr. Arms and Mr. Henry can let me know. Because what I have in mind to do at some point is like a live stream where I actually have a robot next to me and maybe a second camera setup that's looking at it. And we can really start from scratch, look at the wiring, program the robot, have it run, stuff like that. And it wouldn't be doing anything crazy. We might have to break it up into multiple sessions, but I feel like that could be really helpful for you guys. So let me know what you think of that. Let Mr. Arms and Mr. Henry know what you think of that, and we might be able to make that happen. And I'm just kind of talking since we don't have any other questions, and I'm waiting until 2 to start my next session. Mr. Arms seems to think it's a good idea. And I would have mentioned it to the first RGV people before today, except for the fact that I just had the idea right now. Awesome. Okay. We'll tell you what, why don't you guys keep throwing your questions in the chat? I am going to go get some water. If you guys need to go get a snack, go get some water, go to the bathroom, whatever, do that right now. We will be back here at 2 p.m. And I don't know if we're going to leave the stream up or not, so I'll let Mr. Arms take over on that. But that's when I'll start the actual FRC code portion of this session. Okay, awesome. I'm just going to turn off my video then and leave it on the contact slide, and then I will be back at 2. Are we still audio streaming? Okay, that's good.
we are back with Dylan with the BroncBotz. Dylan, take it away. Sorry about that.
Or WPI lib. And that is all of the code you can use in your robot to interface. Basically, it provides an abstraction between your code that you're writing and the robot itself, the motors, the solenoids, stuff like that. We use VS Code or Visual Studio Code to write the software. You can't just go download Visual Studio Code. There is a special WPI library installer for that, and that can just be Googled like WPI lib FRC installation. There's a whole walkthrough. And then the cool thing is the compiler, the deployment, all the stuff that actually make your code is all built right into the WPI lib environment. So let's take a look at this. The first thing actually I want to do. So the first thing I want to do is actually, as per request of some people, I want to share and go walk through really quick the docs. So WPI. So this here, so I just Googled WPI lib FRC 2020 docs. It's this docs.wpilib.org. This is your WPI lib documentation. So this is going to take you not only through your software, but through your control system. So all the wiring stuff of the presentation we did last month, imaging your Rio, programming your radio, updating, configuring stuff, and then benchtop test program. So, actually coming in here, how to make a new program, how to build it, how to deploy it, stuff like that. And we're going to go through some of this today, but not all of it. So I highly encourage you look at this. I can actually, yeah, so it's at docs.wpilib.org right there. Basic programming, all that kind of stuff. Somewhere on here, actually, there is a, I'm looking for the installation. So that's another important part of this. I know it's on here somewhere. Basically, there's an installation of like, hey, here's how you install the Visual Studio Code and all that kind of stuff. The other really useful thing in here is this WPI lib C++ API docs. If we click on that, that takes us to another website, first.wpi.edu. This here is the straight raw documentation for WPI lib C++. Because obviously WPI lib also exists for like Java and LabVIEW, I think. It contains the class lists and all of the different pieces that you're going to be using. So if there's a specific piece of WPI lib that you're confused on and like Chief Delphi isn't answering for you, you can go look at the raw, what all the methods are, the variables are, all that inside that class. And I'll be dropping the link to this in a second. So basically, if we look at like, let's look at FRC, something simple, encoder, right? You can actually click on encoder and we can look at functions that the encoder has that you can call. So getting the scale, getting the raw, getting the direction, getting if it's stopped or not, right? The explanations for all of those and all the parameters, and that works for every class. So if you're ever having like an error with like your WPI lib functions, that's a really good way. It also shows inheritance, which is not something we will be going over today. Polymorphisms, you don't necessarily need that to do FRC. If you're interested in learning it, either Google it, or if you're in a computer science course, you'll learn it there. And I am going to drop this. Mr. Arms will be putting that docs WPI lib link in the live chat, I believe. Also, just a fair warning before I jump into the VS Code, because we're going to be kind of freeform coding some stuff today. I'm not sure exactly how long it's going to take. We might run right to 3 o'clock and we might be done a little early. So we're just going to kind of roll with it and see what that looks like. So robot components. So what do I mean by robot components? I mean anything that like receives a data signal and plugs into the Rio. So, or in the CAN bus. So like motors, solenoids, encoders, sensors, the radio, a bunch of other things, but those are like the big ones for your robot, right? All of that is represented as classes or objects, like we learned about in the last session, within the WPI library. The WPI library represents an abstraction layer to aid with communication between your robot and your code. And everything begins in the file robot.cpp. So we learned in the last session that every C++ program begins with an int main, right? Like a main function. While that is probably true, that main function resides in the WPI library, so you won't actually see it yourself. Instead, you're going to see a robot.cpp that WPI lib actually gives to you, and we can edit off of that. So let's talk about feature requirements. Every time I sit down to do a computer science project, so I'm actually in a hackathon working in it right now. That's what I was doing before the presentations, what I'll be doing after. I also do some computer science work for my university and my computer science classes. Anytime I do anything, I sit down and I make a feature requirement outline to require, okay, here are all the different things that my program needs to be able to do. Here's roughly how I think it's going to work. And is there anything I'm not sure how to do? So the most basic FRC code, I'm talking if you built your robot in like a day before competition and you showed up to competition and you had no code, what would your code have to do if you were writing it all super last minute? The answer is pretty simple. It would have to do two things. The first is take a joystick input, and the second is set an output to the motors to make them run. If you can do that, you can drive. Now, you might not be able to drive well. You might not be able to drive straight or even in the right direction, but you'll move, right? So that's where we're going to start, and then we'll build off that. A basic FRC C++ program can be accomplished really, really easily. One thing there is to note is there's a number of different, I think they're called frameworks or templates that you can use. We're going to be looking at timed robot today. There's also simple robot, which you're not supposed to use because it's deprecated, and then command-based. Command-based, I am not familiar with. I'm just letting you know. So I will not be going over command-based today. I encourage you to go read those docs on the WPI lib site to figure out command-based, or to go to Chief Delphi, because I am not familiar with that in the slightest. So let's look at a sample, and that's all for the PowerPoint slides. So we are going to go look at VS Code, and we are going to start programming. So I have this little plan of action of things I want to go over today here in the comments. But first, we want to look at, so let's make a new window, and I'm going to show you how I got to this point with all this code here. If we go to new window, oh, I'm not sharing this window. My bad. Let's just share the whole screen. Perfect. If we go to this new window here that I created, we can do, I believe it's in, it's in here, this W. So this W here is the WPI lib logo. Click on that, and we can go create new project, okay? Create new project. This takes us to the WPI lib project creator. Now, the WPI lib project creator actually allows you to have it generate a project for you. So you can select an example or a template. And earlier, somebody asked, where can I find good sources for good like examples? This is definitely, by no means is it the only source for that, but it is a good one. So if we go to example, you can see a lot of different things. So motor controller with an encoder, a relay, PDP CAN monitoring, solenoids, encoder, arcade drive. It gets pretty advanced, like intermediate computer vision, HAL exclusively. Not even my team uses HAL. Some stuff in here from like 2019. So there's some pretty good stuff in here. Or you can do template. So if we do template CPP for C++, we have command, which like I said, I'm not all that familiar with. time robot, timed skeleton, which we're not going to look at. That's just the time robot, but it comes with less stuff. It's if you want to write more stuff yourself. And then robot base. That's that. It used to be called sample robot, and then it was called simple robot. You're not supposed to use this too much anymore. So we're going to look at timed robot. You would create a folder for it to go into, project name, team number, and you would generate the project. I'm not actually going to do it because I already did that. I did that in here last night, and then I added these comments into it, but that's all I've done. I've gone in here, I've added these comments, and that's it. So this is basically exactly what it'll look like. So on your left here, you'll have this outline. The folder that you really need to worry about is SRC. So SRC in computer science usually means source. Inside of the source folder, we've got main. So that's going to be your main. You also have a test folder where you can put other things. I'm not exactly sure what goes into this test folder. So I can tell you that in my, how many years now of working with FRC? What am I, a sophomore in college? So 4 or 5. In my 6 years of FRC, I have never once used that test folder. Nor have I used the deploy folder. This deploys things onto your RoboRio. You can read about that in that example.txt that comes with it. But mostly you're going to be using main, CPP as your folder, and then robot.cpp. And this is the main file you're going to start with. You can create other files in here if you want to look up how to link C++ files together, like how to write them and include them and stuff. We can either talk about that at a different date on a different stream, or you can look it up. But for now, we're going to be writing in here. So ignoring all of my comments here, ignoring those comments, here's what we've got. We talked earlier about a class. Oh, look, there's our int main. We talked earlier about a class and what that does. And so you've got a class. A class is kind of almost think of it like a blueprint for an object, right? And so I've got a class called robot, and this here is an inherits. We're not talking about polymorphism or abstraction. So if you already know about it, cool. If not, you don't really need to, because this is auto-generated. Basically, just know what inheriting does at a most basic level is it allows whoever wrote the library to give you access to certain methods that you can customize using the override keyword. So we've got teleop periodic. And again, if I was in a live audience where I could actively see the chat or I was talking to them face to face, I would say something like, who can guess what teleop periodic does? And the answer would be, well, it calls the method periodically or in a loop over and over and over again. So basically everything in here inside these brackets here gets called over and over and over again. Then we've got private. Technically, the difference between public and private is that private, only things within a class can access private. So only something within robot can access these, where something outside of robot can't. Not all that important to note. Just be aware that they're there. That could all be public if you wanted it to. So you've got your joystick, and this FRC : joystick means that this is a WPI lib joystick. And then you've got PWM Victor SPX. So one of the things that I preach, and part of the reason why, if you were on the last session a couple of weeks ago, I was giving the wiring session with the current team captain of BroncBotz, Riley. Part of the reason I help with that session is because I believe that every programmer should know at the very least the basics of wiring, because in the code, you really need to know what the wires look like and envision the robot control system in your mind. So I think that every programmer should also be a wiring person. Even if you're not the one who actually does the wiring, you should know it like the back of your hand. So a Victor SPX is the newest, well, not the newest because the Falcon's the newest, I guess, but it's one of the newer Vex Pro motor controllers. So that's the thing that it plugs into the motor on one end, the P2P on the other end, and then it goes to the CAN bus. However, PWM actually specifies that we're using it by plugging it into the Rio, not putting it in the CAN bus. For a lot of these things like CAN Victors, Talons, the Rev stuff, you need to install separate libraries outside of the WPI lib. That's all very well documented on those docs.wpilib.org. It tells you about installing, they're called vendor libraries. And that allows you to use the VEX products and the CTRE products. That's the cross-road electronics, stuff like that. So we've got one of those, and these are variables, right? So we talked earlier about like int variables. So like int I equals 5, right? All we're basically doing here is instead of int, it's FRC PWM Victor SPX, and that's an object. So there's a class somewhere in the WPI lib that's called this, and we're making an instance of said object. It's just a variable, right? M underscore motor. Right, so that's all that's happening. Now this here, this requires looking at some documentation to read about. So again, part of the reason why those API docs are useful is if we were to go look at those API docs right now, and I went to PWM Victor SPX, we can see that in that constructor, which we haven't talked about, but that's what basically takes the default attributes there. Int channel is what gets passed in. So that's the channel that the PWM Victor SPX is plugged into. And right now we have it plugged into 0. Same thing here. That's the joystick channel. So actually, just so that you guys know, if you go into your driver station, give it a sec to open. Great. If you go into the driver station and you go down here, if you have a controller plugged in, it'll show things here and you can see which axis is which. If you like play with it, play with the controller, and then you can see which axis is which. I don't have a controller on me, so I can't demo that, unfortunately. I am not at the shop because the school is not allowing anyone in there right now. Then there's this. This is the int main. You should never have to touch this. This int main tells it where to start the program, obviously. And that is some stuff that's some mumbo jumbo that WPI Lab came up with. You didn't really have to mess with that. So what is this doing? This is saying the motor dot set. So calling a function that is inside the motor class called set. We are setting the motor to mstick, which is your joystick, right? And that's your whole controller dot get raw axis. So one of the axes, the little joysticks, 0. So we could write it the same way, a different way here. We could say, because I think that's a double. Yep. We could say double. It's got a chat here, but my chat's not showing up, so that's awkward. There we go. Yeah, mumbo jumbo is a very technical term, by the way. So we could say that we have a double called, input value, let's call it. So again, type identifier equals the return from the end stick. So that's an object, right? That's a variable that is storing a type of a class dot. So we're accessing a function or a variable within the joystick, get raw axis, which get raw axis, if you look on the documentation. So we can go look at that if y'all are interested. Joystick, get raw. Where is it? Huh, interesting. There it is. If we look at it, get raw axis gets the value of the axis. Parameters, axis, the axis to be read starting at 0. Returns the value. Returns a double. There we go. So get raw axis 0. And then we could set this input to. So what are we doing? Axes, joystick, axes, return. Actually, I think it is axes. Return on the interval -1 to 1. So if you take your joystick and you shove it all the way back, you're at -1. All the way forward is 1. Letting it go and letting it rest is 0. And then anywhere in the middle there is going to be a decimal, right? So 0.5, you would be setting your motor to, so we'd grab 0.5 from here. Let's say I have it halfway up. That would be 0.5. And then we'd be setting it to half power. And that would set your motor to go half power. And like I said, we're inside teleop periodic. So this is running in a loop every, I think the default wait time for WPI lib is 10 milliseconds, but don't quote me on that. So every like 10 milliseconds or something, we're setting that input value to that, or we're setting that motor to that input value. So we're outputting that value to the motor, setting it to half power, right? And then as soon as you would let it go, this get raw axis would start returning 0. Oops, start returning 0. And so this would be 0, and so we'd be setting it to 0. So now let's look at a drivetrain, right? What do we have on a drivetrain? How many wheels? How many wheels do we have? How many motors, that is? Let's say it's a pretty simple, it's your standard Andy Mark kit bot, right? It's a gearbox with 2 motors on each side, 4 motors total. So let's do that. Oh, goodness. So we've got our 4 motors, and we need to name them all different. So this is going to be M motor left 0, left 1, right? So those are your 2 left motors, right 0, right 1. And it's stuff like this that I really want to get way more in depth with if we do a really long like programming live stream. I feel like that could be really fun if y'all are interested in that, where we actually sit down, program a robot, and can see it run and can do some fancy stuff like PID. So let's say we have all those motors, right? And obviously this would error now because now this guy no longer exists. Now what we want to do is we want to get the value from 2 different axes. And like I said, I don't remember exactly what axes they are, but I want to say it's like 0 and 5. Or 1 and 6, I think, are the 2 Y axes on a normal Logitech controller that are like Y, so like up and down. I think it's 1 and 5. So we're going to make a note of that. And this joystick object, just FYI, is the entire controller. It's not one stick. It's the whole controller that you hold in your hand. So instead, what we're going to do is we're going to get the double left input. Oh, we need to, yeah. And we're going to set the left input equal to the M stick dot get raw axis 1. Right input 5. And then what we're going to do, let's set it. So we're going to take, oops, Q dot set left input. One, 0, 1. Oopsie. And then that's going to be the right input there. And so what we're doing is we're taking the left input from the first axis and the right input for the 5th axis. And we're setting the left motors to the power of the left input, the right motors to the power of the right input. So that's your basic tank drive right there. That's the whole thing, right? And so that allows you to drive forward. And then if you put your right backwards while your left is forward, your robot will spin, right? You can do turns. I know my team, we have some extra fancy driving stuff, but basically at its core concept, that's our drive. It's a tank drive. And how long did that take me to write? 10 minutes, 5 minutes, right? Now, not to say that you should procrastinate on your code, but I'm just saying the most basic type of FRC code doesn't take long if you've done it a lot. I can probably get rid of this int here. Okay. So how about we do this? We've got our, let's go back to the plan of action here. See what else I wanted to talk to you guys about. Oh, reversals. Yes. So can anybody tell me what the, oh, that's right. I can't see the chat. What a potential issue could be with this, because this actually will not work as of right now. The reason this won't work, just because I can't see the chat like live, I'm just gonna, I shouldn't be asking questions. That's my bad. The reason that this won't work is when you drive, when you build your robot, right? Let's look up. And this is why it helps to be a wiring person and actually a robot person too, because you get to see things like this. Andy Mark, Kitbot, I don't know what it's called. Kit parts chassis, perfect. That's the image I'm looking for right there. Those motors are facing that way. This away, right? These motors are facing this away. The issue with that is that if I run, let's say I set a positive power to these motors, they're going to run this way. That's the way that the shafts are going to turn. I set that same positive power to these motors over here. Oh, really? My screen sharing is broken, huh? Okay. Huh. My bad. Thank you for letting me know. Is that better? I'm going to wait for somebody to tell me that's better before I... Okay, my bad. Is it there again or is it still good? Okay. All right. Sorry. Thank you. Okay, so, you know, these guys are going to run this way with positive power, but these guys are going to run this way with positive power because the motors are facing in a different direction and it's the same motor, right? So like they're all the same type of motor. They all run the same direction for forward, but because they're facing different directions, right? Their faces are 180 degrees from each other. They're going to run separate directions. So basically, if you put both your sticks forward on, oh, I still have the annotation. If you put both of your sticks forward on this code right here, your robot's going to spin. And in order to drive forward, you would have to put like one stick forward, one stick back. Now, it all depends on how your robot was built and what side of your robot you consider to be the front for this next part. So I'm going to guess, and typically you would guess this, and then if your robot drives backwards, you would flip it. So I would say a couple things we could do. We could set left input negative. We could input the negative left input, right? We could do left input times -1. And what I meant by flip it is if it goes backwards, then you should do this through right input instead of your left, right? You could do left input times -1. You could even do, and this is probably the way I would do it, right there. So now left input is equal to the get raw axis times a -1. So that right there would be, hopefully, an actually functioning tank drive. So I've got a couple other things I want to go over, and it's 2:30, so we got some time. I don't know if we'll make it through everything, but that's okay. Next, let's say you have an intake on your robot. And the reason for an intake is because they're easy to program usually. So we're going to make, see, this is going to be, then we're going to define, I'm just commenting this out. That's usually a good idea to do. It helps you keep your code clean. So like drive motors. And then here we're going to define intake. And we're just going to take one of these, pop it down. Oh, so I'm disappointed in myself here. So these can't all have the same number here because this is the port that it's plugged into on the RoboRio. So actually this would be like 1, 2, 3, and then I'll make this one 4. And then this is going to be your motor intake. And let's just, to make it more realistic, let's put a joystick in here and have that be the operator joystick. So that's the operator control. So now, but we don't necessarily want it to be, you don't necessarily want your intake to run on an axis. You would probably more likely want it to run on a button, right? So let's try something like, so we're going to have another double called like intake input, right? And I'll assign something to that later. And then we're going to take our intake motor and set the intake input. So in order to do a button on a joystick, and that's why I'm doing this, is to demonstrate how to do a button, we would do m_stick dot get raw button, I believe. But I'm certainly not an expert, and I also haven't actually been a student on an FRC team in a long time. So if I'm not sure about that, I can come in here and do get button. Check that out. Hey, look at that. And interestingly enough, it actually returns a Boolean. So I got this wrong over here because that returns a Boolean. That shouldn't be a double. That should be a Boolean. So again, in a live audience, I would ask, what's wrong with this? There's actually two things wrong with this. And hopefully somebody would answer. Hopefully somebody would answer, and they would say something like, well, the first is, I didn't pass in a port for the button. So again, there's multiple buttons on the joystick. So let's say we just get button 0, and on a like a Logitech or like an Xbox or whatever controller, I think that's A. I think that's like the left button on the right panel there. But I don't remember completely, but you can check that in the driver station as well. The next issue is set doesn't take a Boolean. Set takes an int. Not an int, sorry, a double. Set takes a decimal, a double. And it's a power from -1 to 1. But Boolean is true or false. You don't necessarily want your intake to go full speed. So how would we do this? Because here we could just take the input from the axis and drop it right into here, because the axis is already scaled correctly to what we want it to be. But this, a button requires a little bit more finesse, because a button isn't scaled to that. It's only 0 or 1 or true or false, right? Here's what we would do. We'll use those fancy conditional statements from earlier and say if intake input equals, that's the equals to operator, right? True. If it equals true. True is a keyword, so you no quotes or anything, just true. You could do true and you could do false, right? So if it's true, need them curly brackets in the formatter there. If it's true, set it to, and we could even do like double intake speed. Or it could be called intake output, whatever. And we're going to make it an arbitrary 0.75. So this will run the motor forward, because it's positive value, at 3/4 of full power, because 0.75, right? Whereas full power is 1. So then we want to say else. And we want to make sure, because if we never have an else statement here, the way that WPI loop works is if you set a motor to a power, it's going to continue running at that power until you set it to 0. So even if we didn't have this else and we just left it like this, the motor would be off, and then as soon as you hit the button for the first time, this would be true, and it would set the motor to that power, right? But then immediately afterwards, if you let go, we never set the motor back to 0, so it would continue to go at that power. Now here, input becomes 0, right? But intake speed, this should be intake speed. That must have been confusing. Intake speed is always 0.75. So what we need to do is else. So else will only, this code block will only run if intake input is true. This code block will only run if this isn't true. So else and let's set that to 0, right? And so now what we're saying is, for each time this method runs, because we already established it runs over and over and over and over again, if the intake button is being hit, the speed that we want to run it at is 75%, or 3/4. We're going to set it to the intake speed if the button's being pushed. If not, we're going to set it to 0, right? Now let's say we wanted one button to run it forward, one button to run it backwards, and then it to be off when you're not hitting a button. You could say, we could have another intake input. So bool intake reverse input. mstick, we're going to say it's on the button number 1, just for simplicity. Else if intake and then we would just run it in reverse. So I would do like intake speed. That would reverse the intake speed, right? And so now, if we push button 0, it's going to go forward at 75%. If we put button 1, it's going to go reverse at 75%. And if we hit nothing, it's going to stay still. The interesting thing happens if you were to pick up the controller, and hit both 0 and 1 at the same time. What would happen is it would go forwards, not backwards, because if gets evaluated before else if, and whichever one of these runs, it skips to the end. So if intake input is true, it runs this and then skips down to here. But if intake input is false and then this is true, it runs this. So if button 0 is being hit, it ignores button 1. Hopefully that makes sense to everybody. Now let's say we don't need the reverse anymore. I'm just running you through like different scenarios here. Let's say you had something, when would you have used this? You may use what I'm about to do intakes are good examples. But let's say you had a motor. I don't know why you would want this, but let's say you had a motor that you wanted to be always running. It's always on, except for when you hit a button. When you hit a button, the motor stops. And when you release, the motor starts back up. The easy way to do that would be to do 0, intake speed here. What that would do is it would say, hey, if the intake input is true, set it to 0. So if we're hitting the button, set it to 0. Else, so literally any other time, anytime we are not hitting the button, anytime this returns false, set it to intake speed. So that would be you're driving your robot around doing all your stuff, the motor's running, and then as soon as you stop, or not as soon as you stop, as soon as you hit the button, motor stops. Does that make sense to anybody? I can pause for a minute for questions if anybody's got questions. We don't have too much time left. I'm probably only going to go for another 5 minutes, probably. All right, the last thing I'm going to program is something called a toggle button. So what if we wanted something where, and I'm going to comment this out, that way you can really see it. So let's clean this up a little bit. Format that. Yep. Drop this down here. And we're going to say, okay, intake input, we got the input there. Let's say you wanted a button. Turns it on when it's clicked and turns it off when clicked again. Let's see if we can logically get through this in the next 5 minutes. If not, it'll just be your homework to figure it out. So we take the input every time the loop goes through. If the input on the button is true, right, what do we want to do? We want to say, so we probably want, the first thing you're going to want is a Boolean outside of the loop. So that'll go down here. And we're going to say bool is active. It's false. So when we start, we don't want our motor to be active, right? So if is active equals false, and then again, we're trying to create what's called a toggle button. Hit it once on, hit another off. If intake input is true, and let's, how do we do this? Hang on, I might not be able to do this one in time. Maybe this was a bad example to give. This can actually take a while. If intake input equals true, basically here, I think we're just going to pseudocode this out because we probably don't have time to actually write the code. So we want to check for button input. If button is pressed, reverse the is active Boolean. That would mean, if is active is true, set it's false. If it's false, set it's true, right? Then also set, so we'd want probably another Boolean down here called bool is pressed. That would also be false. So this would actually be if button is pressed and is press is false. And the reason for that is because your loop runs faster than your button. So if you hit the button, chances are your loop has run 3 or 4 times by that. And so if you don't do this, your thing's going to go da, 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 because it's going to turn on and off as you hit your button. Right, so reverse the is active Boolean, set is pressed to true. Else if button is not pressed and is pressed is true. So this condition will only fire the first iteration of the loop when you let go of the button. And this condition will only fire the first iteration of the loop when you press the button. If the button's already been pressed before, that's what this is pressed is, this won't run. So then we would say reverse the is active Boolean, set is pressed to false. And then down here, I think we could do if is active, set output to motor. Else, set no output, set 0 to motor. There we go. I think that would work. I'm not positive. We'd have to go through and test it. And that's kind of why I want to do one of those live streams. So you can really see like the debugging process and stuff like that. But hopefully what that would allow you to do is do push again, turn on, turn off, stuff like that. So with that, what I would like to do is open it up for any questions that you might have. I also want to re-show you this. Again, we've got our resources page. We've also got our contact us. Please feel free to email me. I am always more than happy to help with programming problems, programming issues. Also, if there's ever, if you'd ever like to set up more of a one-on-one type of thing with maybe me and some people from your team, if you're a coach, you want me to sit down with your team, or if you, if you just as a person want me to teach you how to do some stuff and walk you through some stuff, I'm always more than happy to do that. If you want some sort of one-on-one session or one-on me teaching your team type session. Obviously, we're kind of constrained to the Zoom right now instead of the in-person, but I'm more than happy to help out wherever I can. So please reach out to me at that email. I try to answer within 24 hours. And thank you all so much. If you have any questions, please put them in the chat. But it's been great talking to you guys. That's all good.
Yep.
Oh, we're off the stream now.
No, we're still live, and we're just going to pivot over to
okay.
a little chit chat here while we've got your information still up.
Dylan,
that was a lot of great information, and I know that was really hard pressed trying to get all that crammed into these sessions. I do like your idea though about writing some code, dumping it on a robot, and seeing what it does. And I think that would be a good idea. So, Mike, what did you think?
I actually think I really think having some way to do this where you can demo what the code does on a robot, or maybe to even make some on-the-fly changes, that would be really awesome. I just don't know if we can do it with not having access to your shop, Dylan.
So Riley has our 2020 robot at her house.
Oh, that's right. I forgot. You guys are very fortunate that you pirated your robot away to do that. And
Absolutely.
so maybe for November or December, you could, because we're gonna plan to have two more of these FRC workshop weekend kind of things, and
Yep.
so I don't know if you could be ready for November, or maybe December is more likely, and that might be a great workshop where you could. Um, I almost envision taking request. Can you make the robot do this? And
Yeah.
And I think that would be an easy thing to do over Zoom. I think
Oh
Zoom
yeah.
would allow it to be a little more personal, because the way we're doing it now is more just for broadcast. But we would be glad to host a Zoom
Oh, one where I
opportunity.
could be like directly in the chat and talking to people and stuff.
Correct.
yes, and where they could talk verbally to
Mhm.
you also, because you can still fill up the Zoom, and then you can broadcast on YouTube without any.
Yeah, it
I
could
mean,
live
it just,
forever on YouTube. Yeah.
yeah, it
Yeah.
just gives you this nice interaction with the Zoom back and forth. And
Absolutely.
so I like
Well,
that. And I think this was an amazing workshop that covered
oh well,
so
thank you.
much information. And thank you for doing for going to the WPI library and showing
Mhm.
how that can be used. Um, I know a lot of teams do have issues or questions uh, more on the setup, like what you have to download, how you get everything ready before you can even start programming.
And
Uh,
and I'm telling you, man, that would be a whole hour-long presentation all in itself, which is why I don't include that kind of stuff.
oh no,
Um,
you're right. That's something that is a workshop in and of itself.
yeah,
I don't know
yeah,
whether to call it, I guess you call it FRC controller setup. I don't really know what the title of the
right,
workshop would
right,
be,
right.
but it would be something along that line. And
Well, as far as like a live stream for programming goes, or like a Zoom call for that, it all really depends on my schedule, because as far as like having to prep anything, I don't really have to prep anything. Um, well, that's a lie. We have to put the wiring system back on the robot. But other than that, um, it can be ready to go. At some point, I can probably make that happen. Um, and I would love to. Yeah, it's just like I think the request thing could be really cool. So two issues that I have with doing presentations in this format, not issues, but things that make it challenging, is one, like you said, there's so much more that I want to dive into that like I can't, and two is that one of the things you can't show in these is your thought process and your
Right.
debugging. Like when you upload something to the robot and it's like, no, I'm not going to drive forwards. I'm going to drive backwards because I'm not going to listen to you, right? And like figuring that out. So I feel like that'd be really cool. So maybe we can set up a date. I just have to check my college schedule and stuff like that.
Yeah, just check your schedule and let Mike and I know, and we'll be glad to do that. On that note, I think we'll go ahead and close out our live stream today with Dylan Watson from Team FRC 3481 BroncBotz in San Antonio. Thank you for helping us out today, Dylan, and we will see
Thank you.
you all very soon.
All right. See y'all later.